Welcome back, guys. We are going to be doing some more logic puzzles on the Brilliant app. So we're into the second category now. So I don't know if this is going to start off easy because it's a new category and get harder, or if it's going to continue on the difficulty from the last one. I'm not sure. So let's find out. Fallacies. Welcome to Languages of Logic. This course will use puzzles and intuition to explore languages and visualizations of three different branches of logic: syllogistic logic, proportional logic, and first-order logic. By the end, we'll use logical deductions as a tool to understand and build artificial intelligence. The first lesson asks you to decide whether particular strings of reasoning are valid or invalid. Some can be solved with intuition, some are trickier. Okay. Right then. Consider the following argument. All planes have wings, therefore all things with wings are planes. Well, that's not valid. Okay, here's another argument. All Bigfoots are monsters. All monsters are scary, therefore all Bigfoots are scary. Yep. Okay. All bees are busy. No slow things are bees. Sorry, no, it'd help if I read the question properly, wouldn't it? All bees are busy. No slow things are busy. So no slow things can be bees. All bees are busy. No slow things are busy. Therefore, no slow things are bees. Why is my brain struggling? Right, let's try this again. All bees are busy. Yep. No slow things are busy. Therefore, no slow things are bees. That's correct. All knights are brave. All skilled people have done practice. Therefore, well, I don't even need to read the rest. That's four completely separate things. All knights are brave. All skilled people have done practice. They have no correlation with each other. Therefore, some knights have done practice. That's got to be invalid. No pixel aliens are bright yellow. All bright yellow things are from planet X. Therefore, no pixel aliens are from planet X. Right, let's read that again. No pixel aliens are bright yellow. Right, bear with me. I'm going to need some pen and paper. Right. No pixel aliens are bright yellow. So pixel aliens can't be bright yellow. Okay. All bright yellow things come from planet X. Okay. So that's not saying that all things from planet X are bright yellow, though. That's just saying all bright yellow things are from planet X. Right, so all bright yellow things are from planet X, but not necessarily all planet X are bright yellow. Therefore, no pixel aliens are from planet X. Right, let's read it one more time. No pixel aliens are bright yellow. Therefore, no pixel aliens are from planet X. No, because we've established that just because all of the bright yellow things are from planet X, That doesn't mean that all things from Planet X are bright yellow. Therefore, no pixel aliens are from Planet X isn't part of the same equation. This doesn't rule this out, basically. So it's invalid. Great. Okay. No rivers are dry. No dry things are frogs. Therefore, no frogs are rivers. Right, so no rivers are dry, so rivers have to be wet. No dry things are frogs. So that means frogs have to be wet. Therefore, no frogs are rivers. That's irrelevant. We haven't got that information. Because rivers are wet, frogs are wet. Therefore, it's possible that frogs are rivers because they're both wet. So let's just read it one more time. No rivers are dry. No dry things are frogs. Therefore, no frogs are rivers is an invalid argument. We don't have that information. Okay. The arguments in this lesson are from a branch of logic called syllogistic logic, and the arguments themselves are called syllogisms. Syllogisms can be about any topic, bees, aliens, politics, morality, but there are only a few structures that the arguments can be written in, many of which you just saw. The dangerous ones are those syllogisms that sound valid, but that they are actually invalid logic. And it is particularly easy to believe that the logic is sound if you already believe or want to believe the final conclusion. This is the case in the immediately preceding puzzle. No rivers are dry, no dry things are frogs, therefore no frogs are rivers. Be on the lookout for people using this logical structure in real life. If you already believe in the conclusion being that no frogs are rivers, it may seem like the two preceding statements are logical proof that the final claim is true. And it just gets trickier if some of the given statements in a puzzle might be lies. Good luck. I feel like I'm gonna need it. That's what's next. Oh god. Okay. Right. Right. I'll see you in the next one. Right. Next one. Knights, knaves, and logic. On a certain island, there are only two types of islanders. Knights who always tell the truth. Well, this is similar to the robots, then, is it? Was it the robots? No. Yeah, humans are robots. So knights are humans, knaves are robots in the sense of the previous logic. But we'll forget about everything that we've learnt in the past and try and just concentrate what we know here. So on certain islands, there are two types of islanders. Knights tell the truth, knaves always lie. You meet two islanders named Aditya and Bowie. Bowie is a knight and I am a knight. Aditya is a knave or I am a knave. Okay, so if this was true, then this can't be true. And if this isn't true, that means he is a knave, which means that this statement means that she is a knave as well. So they're both knaves. In a min. It means that she's definitely a knave. Let's just look at this one more time. Aditya is a knave, or I am a knave. I don't like that or. I don't like that or being in there, because We know that Aditya is a knave. So this or, let me have a think about this. Right, so for Bowie to be telling the truth, Aditya is a knave, then that means that Bowie has to be a knight, because a knave can't lie about Aditya being a knave, because then that would make Aditya a knight. We've already established that Aditya's a knave, so Bowie has to be a knight to tell that truth. So that statement is, if you rewrite this statement, it says one of us is a knave. We've already established Aditya is a knave, so that means that Bowie has to be a knight, and that Aditya is a knave. Fantastic. Right, on the same island, you find three friends named Channing, Dijah, and Ira. Is Channing a knight or a knave? Okay, exactly two of us are knights. So if that was true, Channing is one of the knights. Ira and myself are knights. So it's impossible for all three of them to be knights, because that would make Channing's statement false. So either Channing or Dijah are knaves. So let's pretend Dijah's the knave, so we can ignore. That doesn't necessarily mean that both of them are knaves, it just means that she is, and Ira could be either. So Channing or Dijah is a knave, yeah. So she's definitely a knight, because we know that one of these two is a knave. So which one of these two is? So we know that she is a knight. So if exactly two of us are knights, hmm. It's this statement here. Oh, I can't highlight a picture. Ira and myself are knights. See, now, in my mind, this is saying that it's possible that Ira could be a knight, because this "and" is saying that they're not. So if right, let's reword this. If Dijah is a liar, then it's possible that she can lie about one part of a statement and that the other part is true. Because a liar doesn't need to lie about everything. Oh, but then again, knaves always lie. So does that mean that everything they say is a lie? Because if that's what that means, then she can't be a knave, because Ira is a knight. Yeah, so the fact that, right, yeah. So she's not a joker in terms of the previous puzzle, where she can choose whether or not to lie or tell the truth. She has to lie about every statement. And because we know that Ira is a knight, she has to also be a knight, which means that Channing is a knave. What? Right, okay. Let's see the explanation. Suppose Dijah is a knight, then Ira is as well. Now if Channing is a knave, oh no, that makes exactly two knights. which means that Channing would also be a knight, which means all three of them are knights, which makes... So I was right in my first assumption then. But then in my first assumption, before I decided that she can't be a joker, that would mean that it is possible for a knave to tell a partial truth, and that not necessarily all statements made are a lie. Oh, god damn it, I should have trusted my first instincts. Yeah, I should have trusted my first instincts, and not only that, I should have double checked that I made sure all of the statements were true, because then that would have made all three of them knights. So yeah, that was partially my fault. Well, yeah, I don't know. Let's pretend that this is a different statement. I'm still not happy about how they can tell some truths and some lies. I'm not sure. I feel like this is wrong. I feel like we should know more information. I don't know. I've obviously made a mistake and I'm trying to explain myself out of it. Right, now consider the claim: if it's raining on me, then I use my umbrella to keep dry. The only way this claim is false is if it's raining and the umbrella is not being used. Intuitively, one can't claim a person is lying about using umbrellas when it rains if it isn't raining yet. Okay, right. Let's reread this. Okay, so if it's raining on me, then I use my umbrella to keep dry. We can't say that this person is a liar if it's not raining. So if this first statement is not happening, then you can't determine whether they're lying about the second statement. Okay. Statements of the form if A then B are called conditional statements. They have two parts. A is the hypothesis, which can be true or false on its own. B is the conclusion, which can also be true or false on its own. A conditional is false only when A is true and B is false, otherwise the statement is true. Right. A conditional is false only when A and B is true. Sorry, when A is true and B is false, otherwise the statement is true. Right, I wouldn't have said it was true. I'd have just said the statement is not happening. You can't say it's true if the conditions aren't met. Right, I'm not happy about that. Right, okay. So if I'm not happy about this, that means I'm gonna have to try and use this into my thinking, even though I'm not happy about it. So let's highlight it. You come across two more friends named Fiad and Greg. Fiath? I've got a feeling this is a Scottish or an Irish name, and I can't quite remember. Fiev I think it's pronounced as a V. That's a funny name, though. I don't know how you meant to pronounce that. If you're not from that area, that is not a name that's easy to pronounce. Let's just pretend there's no H. Fiad. Right, you come across two more friends named Fiad and Greg, but only Fiad. I think it's Thieve. Anyway, that's irrelevant. Only Fiad says anything. If I am a knight, Greg is a knave. Is Greg a knight or a knave? Right, right. This is what I was saying before about this. I don't agree. I don't agree with this. I'm clearly not as clever as the person who made the test. But I don't agree with this because you can't prove that a statement is true if you can't even identify the statement because we haven't met the conditions of the statement to prove that it's true. So, to me, the statement is unknown, not the statement is true. But according to this, the statement is true because the alternative is unknown. I'm really not happy about this. So, in my opinion, the answer should be this. But because of this, and because it says you'll need to use this in the next question, I think we're going to have to say knave, aren't we? Even though my instinct tells me that we don't have enough information, because we don't have enough information. So let's say, for example, here that Fiad is a knave. And if Fiad is a knave, then Greg is lying about. Sorry, then Fiad is lying about Greg, which makes Greg a knight. That's if Fiad is a knave. But we don't know if Fiad is a knave or a knight. So we can't come to a conclusion on what Greg's identity is. So to me, the answer is there's not enough information to be certain. But because of this statement, which I don't agree on, I think it's trying to tell me that I have to choose knave as an answer, even though I'm not happy about it. So let's do what I think it's trying to tell me, rather than what my instinct says. See, yeah, I don't agree with that. I don't agree with that. We don't have the information. Right, let's have a look at the explanation. Suppose Fiad is a knave. Right, that's what I wanted to suppose. That would mean that his statement, if I am a knight, Greg is a knave, is false, because knaves only make false statements. Right, but a conditional is only false when the hypothesis is true, and the conclusion is false. The hypothesis is Fiad is a knight, which contradicts our assumption that Fiad is a knave. Therefore, Fiad is a knight, and the conditional is true. So Greg is a knave. What? Right, let's see if I can get my head around this. No, I still don't agree. I still don't agree. I'll explain why. A conditional is only false when the hypothesis is true, but the conclusion is false. Well, we can't come to a conclusion because we don't have the information of whether or not Greg is a knight or a knave, because he hasn't made a statement to say whether he is one or the other. So we don't know. So we can't come to the conclusion that the hypothesis is true or false because we don't have the information to decide whether they are being truthful or honest. So it doesn't contradict our assumption. See, they're saying the hypothesis, Fiad is a knight. Well, there's more to it than that. There's more to it than that, because Greg is a knave is also part of the hypothesis, which leads me back to... Oh, is it on the previous page? No, knaves who always lie. Leads me back to this one, where I was saying they have to both be lying. To me, these two don't add up. This question, Bowie is a knight and I'm a knight. I was saying that if they are a knave, both of theirs has to be false. But the answer told me that they can have part false and part truth. Where with this one, Fiad is a knight is only part of the statement. So we can't prove anything from this because there's a second part of the statement that we can't verify. So it's possible that the whole statement can be a lie, even though part of it is true. I don't know. I don't know. This seems wrong to me. I feel like both of these can't be true. You know, like both of these can't exist at the same time. You can't have one question where part of the statement is true and part of it is false. Or was it this one? Sorry, not the top one. Dijah. Is it because there's no comma here? Is that the thing that separates them? There's a comma here and there's no comma here. And so this one is separating them, so it's two different statements, where this one isn't separated by a comma, so it's not two different statements. Is that what the difference is between the two? Right, I don't know. I don't know. So I got the answer right because I could tell by the way the question was worded that that's what it wanted me to say, but I still don't agree with the reasoning. Right, so let's read it one more time. Suppose Fiad is a knave. That would mean that his statement, if I am a knight and Greg is a knave, is false, because knaves only make false statements. So they're separating the two out with a comma. I think that is the difference that's going on here. I think it's this comma. So if I am a knight, then Greg is a knave. I think that comma should be a then instead of a comma. Whereas up here we didn't have a then. And so they could exist at the same time and part of it could be a lie. It wasn't an if and a then. It was a whole statement with part fact and part lie. Right. Okay. So I think that is what's going on here. I'm still not sure. I'm still not sure about this. A conditional is only false when the hypothesis is true and the conclusion is false. Well, we can't come to a conclusion because we don't know the state of Greg. We don't know if he's... So is it saying that the hypothesis isn't true? The hypothesis isn't true because if the hypothesis was true, then Fiad would be a knight. And if Fiad would be a knight, he'd be telling the truth. So is that what's going on here? Is it this part that I'm getting confused over? The hypothesis is Fiad is a knight. Right. Oh, damn it. My internet's gone down. I think that's where I'm going wrong there. Right, bear with me. Right. Internet back. Right, okay, so I'll try and go through it one more time, giving my logical path, my reasoning. Now let's say for example that I am Fiad and that you are Greg. So in this situation, it's saying that Greg is a knave. So it's saying that you are a liar. Now, if me, Fiad, am actually the liar, then I can say, if I am a knight, then you are a knave. So if I am telling the truth, then you are a liar. But what if you aren't a liar? What is stopping me from saying that? What if you are completely truthful? How does that stop me from making the statement? If I am a knight, then Greg is a knave. So if I am telling the truth, then you are a liar. If I am a liar, then you are telling the truth, which would make Greg a knight. Because I am a liar, you are honest, you are telling the truth. So I don't see how them two are mutually exclusive, which is what I was saying about this. I don't see how just because the first statement, a conditional is false only when A is true and B is false. Right, let's read. Sorry about this, guys. I need to try and get this through my thick skull. A conditional is false only when A is true and B is false. Otherwise, the statement is true. Right. But why can't it be false if A is false and B is true? Why can't that be? So if A is false, that makes me a liar. And if I am a liar, then you are a knight. So I still come to the same conclusion, that Greg is a knight, not a knave. Oh my god. So whichever way round I've done it, I've basically come to two conclusions here. One, there isn't enough information, and two, it's possible that if Fiad is lying, then he's lying about Greg being a knave, which means that Greg is a knight. Yeah. I'm not happy about this at all. Let me know in the comments if you agree with me or or the person who designed the test, who is clearly much more intelligent than I am. Oh, I'm going to move on from this, otherwise my brain will explode. Okay. Finally, just as you are about to leave the island, you find a group of 4 islanders named Cade, Lovelace, Maxwell, and Nellie. Okay. Each one of them is saying the exact same statement. Maxwell is a knight, or I am a knight. Well, or is impossible. It has to be and. And if they're all saying the same thing, they are all impossible, which means that they're all liars. Given you know at least one of them is a liar, exactly how many are liars? Well, they're all liars, because none of their statements can be true, because they're all the same statements. Right, well, that's a bit easier than the previous one. Jesus. Right, okay. I think I might have to call it a day for this one. Right, I'll do one more. Knights and formal logic. Oops. Knights and formal logic. Propositional logic was derived from the rigorous exploration of both philosophy and mathematics and has been used to study logic since the 3rd century BCE. This course will teach you this language and show you how to apply it through solving puzzles. Later in this course, you'll learn to apply propositional logic to more serious applications in programming and AI. Let's jump right in. Okay, on the island of Knights and Knaves, where knights always tell the truth and knaves always lie, you meet 2 islanders named Penny and Keenru. Both Keenru and I are knaves. Well, that's impossible. That's impossible. Because if Keenru was a knave, Penny wouldn't tell the truth about it. So that means that Penny is the knave and Keenru is the knight. Right, happy days. Formal propositional logic is a powerful language for working with logic, similarly to how algebra is a powerful language for working with numerical unknowns. In this lesson, we're going to introduce the basics. Okay, this might be a problem for me because I didn't exactly do much work in school. I wasn't a very good student. Oh dear. I blagged my way through the entire of, well, all school, to be honest with you. I wouldn't say I was naughty. I just, yeah, I didn't do anything at school. I spent my entire time messing about. So, I don't really have any understanding or knowledge of algebra. Right, we'll see if we can get through it though. When translating a problem into formal logic, we give statements single-letter nicknames known as propositional variables. For example, we might refer to the statement "Penny is a knight" as P. Okay. The symbol triple line is called a biconditional. Okay, so that is a biconditional. You can think of it as meaning if and only if. So P, if and only if, Q means P is true if and only if Q is true. Suppose P, if and only if Q, and Q is false, then P must be false. Is that right? Because Q false, Q true, P true, P must be false. Hey! Oh god, more symbols. Okay. The symbol, whatever that is, negates a propositional variable. That is, this is the negation of P. It's read as not P, so the opposite. So that means the opposite. So that symbol is the opposite of the thing that it's next to. So the other one's called a biconditional. Let's just call this the opposite. Using penny is a knight as P, what does that mean? The opposite of a knight, which is a knave. Okay, similarly to how plus and x are operators, is that x or times? In algebra, I wish I'd have done algebra at school now. And, or, that, and this, so opposite and if and only if, are operators in logic. If x and y are any propositional statements, then, oh my god. Right, okay. If x and y are any propositional statements, then x and y is true only when x and y are true. Yeah, that makes sense. X or y is true when one or both, so or both. So they're not mutually exclusive. X or y are not mutually exclusive. See, in my mind, or is mutually exclusive. You're saying it's either this or it's this, where in this sense, it's saying one or both. So to me, that's and or. That's not or, that's and or. So I disagree with the I disagree with the forming of the question immediately. Because if you say something's red or blue, it can't be both. So or in that statement cannot be both. Oh god. If I disagree with the premise at the beginning, I'm not going to get very far, I don't think. Right, this is the opposite of x is true when x is false, and false when x is true. Yeah, I understand that. X is what does this mean? I can't remember now. Biconditional. You can think of it as meaning if and only if. X, if and only if y is true, only if x and y have the same truth values. So equal to, maybe, if and only if. X, if and only if y is true, only if x and y have the same truth values. So it's basically like saying they're the same, I think. So that symbol is the opposite. That is the same as that. Right, I think that's what's going on here. Okay, truth tables are a tabular organization of all the different cases. You fill them in left to right, and the leftmost columns enumerate all possible true-false combinations of the propositional variables. Here's a truth table displaying the values of x or y, so which can mean and or. Right, okay. Here's a truth table displaying the values of x and or y. X is the same as y, and not y for different truth values of statements x and y. Oh my goodness gracious me. Okay. The values in the last column are for you to fill in which cases will x or the opposite of x, sorry, the opposite of y be true. Select all that apply. Okay. So this, I've got to fill in the category of the thing that I disagree with. The or is the same as and or. Oh, that's marvellous. The one thing that I disagree with is the one thing that it's asking me to fill in. That's fantastic. Thanks for that. So I'm going to have to try and argue with my own brain so I can agree with the premise of the argument, which I originally disagree with. Marvellous. Okay. X is true. Y is true. X or Y is true, which is X and or Y is true. Marvellous. X is the same as Y. Yeah, that's true. The opposite of Y is false. If Y is true, the opposite is false. Yeah, that makes sense. X and or the opposite of Y. Right. Right. I'm going to guess because I don't agree with the forming of the question. I'm going to use logic instead of theory, if there's such a thing. And I'm going to say that X or Y is the opposite of X or the opposite of Y, which means that whatever this table, God damn it, pressing buttons, whatever this table shows, X or Y, is going to be the opposite in this table. So it's going to be false, true, true, true. And that is me using probably the complete opposite thing to what it's telling me. Well, it is using the opposite thing. It's telling me to fill it out from left to right. And I've just basically used a pattern, a logic pattern, to fill in the blank rather than actually do what. See, this is what I did in school. I just looked for a pattern and put that as the answer instead of doing what doing what it told me to do. Oh dear. Right. True, 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 false. I don't get this at all. Right, I've got a feeling I'm wrong here. Right. Here's a truth table displaying the values of X or Y for different truth values of statements. Right, let me just go back up again. X or Y is true when one or both X and Y are true. Right, wait a second. So, X or not Y is still true if one of these is true. And because one of these is true, I don't think my logic thing is going to work in this case. Because X is true, so because X is true, even though the opposite of Y is false, I've still got one truth in here. So that is true. So I don't think that reversing this is going to work. In which cases will X or the opposite of Y be true? So it's going to be true in every case apart from one. And which one is it not going to be true? It's going to be true when x is false and the opposite of y is false. So the opposite of y is false here and x is false here. So this is going to be the one that is false and all of the others are true. So when x is false and when y is true. Right, I believe that is the answer. No, sorry, the opposite of that. The opposite of that. That is the only one that isn't the answer. I think all of the others are the correct answer. When x is false, and when y is true. In which cases x and or minus y, or opposite of y. So it's always true if x is true, and it's always true if the opposite of y, which is y, is true. Oh no. Does that mean it's true when that one's true or when that one's true? One of these two is true. Which one? In which cases will x or minus y be true? So minus y, when minus y is false, I'm pretty sure it's that. I'm pretty sure it's that. Go on, let's submit. Oh, I got there in the end. I'm glad I didn't do what I was about to do at the beginning and just reverse this table. See, reversing this table would have worked if my theory from the beginning is or is actually or and not and or. As soon as you put an and or in, it changes it completely. But they shouldn't use or as the symbols for and or, because and or is not the same as or in the English language, rather than in the symbols for this particular puzzle. So I almost used English language to solve a algebra puzzle, which would have been incorrect. It's only when I read through the rules that I got it right. Well, at least I read through the rules. I'm doing better than what I did at school. Right, okay. Suppose P is a statement, Penny is a knight, Q is the statement, Kinru is a knight. So P is Penny is a knight, Q is Kinru is a knight. How would the statements both Kinru and Penny are knaves be written in formal logic? Well, it'd be... Oh, wait a second. That one. It's got to be that one. Right, okay. Now here's where it gets a bit tricky. On the island of knights and knaves, knights always speak the truth, knaves always lie. To translate this idea into formal logic, we say a statement spoken by an islander is true if and only if the person making this statement is a knight. Okay, makes sense. P stands for the statement Penny is a knight. Q stands for the statement Keener is a knight. And the symbol biconditional, or whatever it was called, means if and only if. What statement corresponds to Penny saying Keenru and I are knaves? Wow. Okay. What statement corresponds to Penny saying Keenru and I are knaves? Well, if Penny's saying that, if we go back to this, a statement spoken by an islander is true if and only if the person making the statement is a knight. Well, we know that Penny is a knave. So I'm going to have to do the opposite of my instincts here. I mean, I haven't even worked it out yet, but I've got a feeling that once I work it out, I'm going to have to choose the opposite of what my instincts are telling me. So let's have a look. Let's see if we can work our way through this. Right. I am fighting my instincts here because using logic to solve the puzzle tells me that Penny is a knave, which means that this should be the symbol for Penny as a knave. But the statement corresponds to the Penny saying Kinru and I are knaves. The statement, I'm not trying to solve the puzzle. This is the conclusion, not the formation of the statement. I think it's telling me to write down the formation of the statement, which is this. So that is assuming Penny is telling the truth. So we would be writing this statement as if it's true. So Kenny, Kinru and Penny being both knaves is this part of the statement. And that part of the statement, for that to be true, then it'd be P is the same as, because we're writing it down as this statement being true. So regardless of what we believe the answer is, we have to form the statement as if it's true. And then the conclusion will be the opposite of P. I think that's what's going on here. So although my instinct immediately went to Penny as a knave, this must be the answer because of that symbol. That is not the answer to what it's telling me to form the question as. That's the answer to the question itself. I think. I don't believe I got that right. Right, okay. I'm happy about that. Let's show the explanation. P is the same as, they're not the opposite of P and Q. When the symbols are turned back into the phrase, means the following. Penny is a knight if and only if Penny is not a knight and Kinru is not a knight. Since being not a knight is the same as being a knave, this can also be read as Penny is a knight if and only if Penny is a knave and Kinru is a knave. Remember, a statement anyone says is true if and only if the person is a knight. So first it's asserted Penny is a knight, and that is associated with what Penny says. If Penny is a knight, what Penny said is true. If Penny is a knave, what Penny said is false. Of the other answer options, Penny is a knave if and only if Penny is a knave and Kinru is a knave. This is essentially claiming if Penny's statement is true that Penny is a knave, but Penny can't be a knave and make a true statement. I feel like I'm in a bowl of spaghetti. Oh god, internet's gone down again. Bear with me. Right, we're back. Since being not a knight, right, we've just read that. We're on the next one. Penny is a knight and Kinru is a knight if and only if Penny is a knave and Kinru is a knave. what? This is the most complicated thing I think I've ever done. The statement here claims two entirely different statuses exactly for the pair. While it's still possible that the original scenario is impossible, we're building our if and only if statement in order to include the fact that knights make true statements, not to kill the truth of Penny's statements before it can even be analysed. Okay, so I think I worked it out right, even though I don't understand the English language of working it out. I think I formulated it properly because it was asking me to formulate the equation, not answer the equation. Right. Now that we've written our statements, yeah, there we go. Now that we've written our statements in formal logic, and that's what I was thinking that it was asking me to do. Let's solve the puzzle. Right, here we go. Here we go. So the answer to the puzzle is Penny as a knave. Let's solve the puzzle in a way that doesn't resort to exhaustively listing every case. We're going to attempt a proof by contradiction, where we assume something is true, then show it leads to an impossible scenario. The formal equivalent of Penny's statement, Keenru and I are knaves, is what I put earlier. Let's assume P is true. P stands for Penny as a knight. Then both of them is also true. What does this imply about them two individually? Right, right. Bear with me. I need to. I need to try and formulate this in my mind. Right, I think neither are true, and I think this goes all the way back to the beginning. Ah, yeah, this one here, where I was saying we can't say. Oh no, it's not this one. I think it's on the previous. Bear with me. Let me read through this again. Yeah, it's not this one. It's the one on the previous page, I think. I'm getting confused, man. I'm getting really, really confused. Is it this one? No, it's not. No, it's on the previous page. Right. But yeah, I think neither are true. Oh, in a min. In a min, in a min, in a min. I've got a feeling that this is the same as this, which is saying that Keenru is a knight, which means that only Penny is a knave, which means that only that is true. So let's have a look at this again. Both Keenru and I are knaves. Now, if that is true, right? Yeah, let's work through it logically here. If she is a knave and she says he is a knave, then he can't be a knave. He has to be a knight because she always lies, which means that Penny is a knave and Keenru is a knight, which means that only that is true. Okay, that's the conclusion I'm coming to. Let's see if I'm right. Oh, both are true. No. Oh, damn it. How did I, how did I, how? How are both true? How are both true? I mean, I know that she's a knave, so I know that's true. But how is he a knave as well? How can that be true? Right. With any and statement being true, the individual parts that make it up are true. If I say I like apples and I like bananas, it must be the case I like apples and I like bananas are individually true. So, the opposite of P and the opposite of Q can be separated out so that also the opposite of P as well as the opposite of Q are true. I still don't get it. I still don't get it. I feel like I'm still trying to solve a riddle rather than answering the question. The formal equivalent, right, the formal equivalent of Penny's statement, Keenru and I are knaves, is this. Yeah, we worked that bit out. Let's assume P is true. P stands for Penny is a knight. Then, this is also true. What does this imply about this? Oh, God. Yeah, we're assuming that Penny is a knight now. No, no, I still don't understand it. I still don't understand it. So, what does this imply? So basically it's saying, let's assume P is true, and P is the same as this. So it's basically saying, let's assume that this is true, which means that that has to be true. So the answer is both of these are true, which is the answer. So I'm understanding it now. It's this bit here, let's assume P is true. So if we assume P is true, then the whole equation has to be true, because that is if and only if. So if P is true, then these have to be true to make P true. But in my reasoning, if P was true, then P is telling us that P is not telling the truth, which means that now P can't be true because P is always lying. And if P is always lying, then that means that Q can't be true, which makes Q. See, that was my understanding of it. So Q had to not be a negative because P is a negative, which automatically means that this P, it's because these are both P. Now, if that wasn't a P, then I wouldn't have questioned whether this was true, which wouldn't make me question whether that needed to be changed or not. I hope I'm explaining that properly. But anyway, if you read it as this is true, and we're assuming that this is true, so that has to be exactly the same as this, then yeah, I agree with the answer. But if that means that this is the opposite of that, then this has to be the opposite as well. Yeah, all right. I don't really understand. Notice the first and third lines, P, are true at the same time. That means Penny is a knight and a knave, which can't happen. That's what I said. That is what I said. And so basically, I've skipped ahead and are doing the rest of the equation without actually doing what it's telling me to do. So yeah, I think I was right in my reasoning, but wrong in my answering of the question. So our original assumption of P being true doesn't work. P can't be a knight. That is exactly what I said. P can't be a knight, which means that Q can't be a knave, which is why I answered only P. Well, I'm happy that I got the final conclusion, even though I answered the previous question wrong. Since Penny is a knave, we know that that is true and that that is false. Let's substitute this into P equals false equals true and is Kinru a knight or an ape? So Kinru's a knight. Yeah, that is the answer that I was trying to give up here. That only Penny is a knave and not both of them are true. That is the reasoning that I came to here. So I'm glad that the final answer came to the same reasoning as what my reasoning was going down. Happy days. Formal propositional logic is in its essence a type of algebra that allows transformation of statements from one form to another. One important use is to systemize and simplify logic problems and let us turn statements like Penny says it's not true that if I am a knave, then Kinru is a knight, into statements like Penny says I am a knave, Kinru is a knave. Right, let's just quickly reread that again. I'll do it in my head. Right, yeah. It lets us handle situations where we might have tens or hundreds or even thousands of variables, perhaps referring to legal codes or DNA strands, where a truth table would be impractical even by computer. In this course, you'll use formal logic to solve some very challenging puzzles that are really only approachable using logical tools you just learned. And we'll also go far beyond puzzles, applying formal logic both to create artificial intelligence and to define some of their limits. Oh wow, I have a newfound respect for developers trying to create AI. This is just, oh yeah, mind bending. That's what it is, mind bending. Well, I need a break. I need a break. So I hope you've enjoyed what you've seen so far. It's so confusing. So confusing. I kind of wish I'd have paid more attention in school now. But I'm enjoying it, and I hope you're enjoying it too. So cheers for watching, and take care, and join me again in the next one. See you soon, guys.